Hello, Professor. This is Gayatri Chilukala. I'm individually working on this project. Coming to today's project, in the world full of data, it's important that the data is fair and square. So, I've chosen this topic fake news detection. Coming to the introduction to the project, the fake news detection is a sophisticated system that utilizes both natural language processing and machine learning techniques to analyze and ensure the integrity of the text data. It is implemented in Python with NLP libraries such as NLTK, which performs the in depth analysis covering tokenization, stemming, and lemmatization. Simultaneously, after the text pre processing, it employs the machine learning models to predict whether the data is real or fake. To enhance the transparency and accountability, the fake news detection incorporates the explainable AI techniques like SHAP and LIME, which not only ensures the content integrity and risk mitigation but also fosters the truth by understanding and making decision process transparent to the user. Coming next to the problem statement, in today's fast paced technology landscape, the distribution of news and information is increasing, and dependency on artificial systems is also increasing. So, the crucial risk of ensuring the responsible and impartial governance of the AI systems is important. So, the primary goal is to advance the transparency and fairness and ethical standards in the system by designing a filtering of the news content. I just want to take an example of the tweet in 2013 which made the stock market down in just fraction of seconds. Two explosions in White House and Barack Obama ensured. This small tweet went viral throughout the Twitter and caused lot of damage to the stock market. On not only this tweet, I'm also taking an example of the COVID vaccination. During the COVID vaccine was released, there were a lot of negative tweets spread on the Twitter that not to take the COVID vaccination. Because of taking COVID vaccination, it does not provide you any kind of assurance that you will not get COVID or something, but instead it can give you some several diseases or it might affect your health by taking COVID vaccine. So it's sometimes important just to take the vitamin C or be exposed to the sunlight. That could be enough. Not even taking COVID vaccine will help you. So there are like several tweets that are spread, wrong assumptions were made and spread amongst the social media. So filtering of the data is very important. So I have taken a data set from Kaggle, which is the fake or real news data set, and it has four columns. One is the unnamed column, title, text, label, which is real or fake data, and it has total 6,156 unique. I have done my project in Google Colab. The initial step of my project is exploratory data analysis, which involves in determining the nature of the data set. First step, I've imported all the important libraries that I'm going to use throughout the code. Next, I've read the CSV file using the pandas. And next, I'm checking if there are any null values in the data set. And next, I'm checking the distribution of the labels like fake versus real. Like you can see, there's a slight imbalance, and you're going to remove this imbalance before applying the machine learning models. Next, I'm just checking the first text length, and next finding out all the text length in the data set and adding as a column in the data frame, that is text underscore length. In the same way, I'm also counting the number of words and adding as a column in the data frame. Next, in the same way, the mean word length text as a column in the data frame. And next, I'm tokenizing the data. Tokenizing the data is like dividing the sentence into words. And this is the clean function, which is going to clean the text, like converting to lowercase, non-numeric, non-string character is converted into null, and also it's removing all the stop words. You are installing using NLTK the stop words. And next, you are applying the clean to the text. You can see after the cleaning process, the text is being cleaned, converted into lowercase, remove non-string, non-numeric characters, and also removal of the stop words. Next, you are creating the corpus after obtaining the words from tokenization. For the analyzation purpose, you plot different graphs from the corpus like top 10 most frequently occurring words and top 10 frequently occurring bigrams and third thing top 10 frequently occurring trigrams. These are all for analyzing the nature of the data set. Next, we are going to remove the punctuation marks from the text and we are going to remove the column because it's not necessary for our analysis anymore. So you are going to drop this column from our data frame unnamed 0 and we are going to consider the words like which are only greater than 2. We are going to remove all the small words which are less than length of 2 and next we are going to apply stemming and lemmatization. Here first we are applying the stemming using the NLTK. After applying the stemming, we are going to next apply the lemmatization, which is more advanced than that and gives an accurate root word than the stemming. And next we are going to plot like we are having like using the word net after word net. Next, whatever the results that are often after all the text processing, we are returning as a new text column. Next, we are going to just print the first 10 records in the data frame. And next, we are going to create the word cloud. In the word cloud, you can see that some words are highlighted, are like more occurring. So you can see the word cloud in the for this fake news. In the same way, it's for the real news. Also, like we are plotting another word cloud. You just check which are the words that are more occurring and which are the less occurring words in the data set. And next, we are also plotting its distribution, fake versus real. And we are also comparing the total number of characters in the feature title, real versus fake. Next, creating a bag of words with consecutive frequency for the fake text. You can see the word associated with its frequency as count. And also you can see the top 20 frequent hashtags. This is for real. Sorry, this is for fake and this is for the real. We are also plotting bag of words for the real text and also top 20 frequently occurring words along with the frequency as a bar plot. And next we are going to apply the machine learning models. The next step after the exploratory data analysis is applying the machine learning models. So the results that we obtained from exploratory data analysis is this: you can just find a small imbalance in the data set that we are going to remove before applying the machine learning models. So first step is to convert the text like fake and real to 1 and 0 label. This is called as label encoding. Next, we are going to divide our data set into test and train. You divide it using test, train, split from sklearn. And we vectorize the text data using TF-ID vectorizer. And after vectorizing the data, we apply the smoothie technique to oversample the minority class to prevent a small imbalance in the data set. So we are using the smoothie technique, which will remove the imbalance in the data set. Next, we are applying the classifier, starting with the random classifier. We get it from the sklearn. We first fit the model using the train data and predict using the test data. For the test data, we are going to find the accuracy and the confusion metrics. And even the same way we are going to do for the logistic regression model, the train data we fit it and next we do the prediction on the test data and find its accuracy and confusion metrics. Next is support vector classification. It is also in the same way. We make the prediction on the test data and we fit the model using the train data and find the accuracy that we obtained using the results from the X test vector. We get even the confusion metrics. So the decision tree is the last classifier. We apply using the train data fitted and make predictions, find accuracy and confusion metrics. And
all the results that we obtain, like first, second, third, fourth accuracy, we are going to put it in the labels and plot a bar graph for comparing all the accuracies that we obtain from all the four classifiers. After plotting, we are going to separately plot each confusion matrix and check the results that are obtained. This is for the random forest, and this is for the logistic regression, the confusion matrix, and this is for SVC, support vector classification, and the last one, decision tree classifier. This is the confusion matrix obtained. Next, after the machine learning models are applied, we are going to apply the explainable AI techniques. After applying the machine learning models, we need to transparently communicate the user the decisions that we obtain from the machine learning models. This is done using the explainable AI techniques like SHAP and LIME. So firstly, we are installing the SHAP over here, and next we are going to apply the TF-ID vectorizer on it, and we are choosing the model one, which is the random forest, and after that we are applying the SHAP explainable AI technique on a text instance. Over here you can see that. So we see that if the text belong, each text, like each set of tokens here in the text are represented here, and each has one probability. So here you see that the positive contribution and the negative contribution. So here, so in this way we get the probabilities for the each token, and on the total, when we total it, if it's greater than zero point 0.5, then it belongs to the positive text. That is the real text. It belongs to the real label. So we can also check another instance which contributes to the like the negative side. Yeah, there's another instance. You can see that all the text over here are having almost the negative probability. So here when we total it's less than zero point 0.5, then this text is a fake text. I mean, it belongs to the fake label. So we are just plotting the best for the best one scatter plot and also the worst scatter plot. The shape, using the shape, we are plotting the scatter. And next we are implementing the next line is the another explainable AI technique to build the trust amongst the results that are obtained from the machine learning models. So we same way we apply the vectorizer, that is TF-ID vectorizer here, and next we apply an instance, the lime technique, and you see that there are more than like many words highlighted over here are blue color, which contribute to the real side of the label, and you see there's only a single word which is contributing towards the fake. So as most of the words belong to the real, so this will be considered as the real labeled text. So in this way, the line method works. This is another explainable AI technique, and these two sharp and line explainable AI techniques communicates decisions transparently and also establish the trust among the results that we obtained. And this is the conclusion for this project.
Coming to the integration of the project, we can integrate in different ways. First is integration in the social media platforms. Real time content analysis should be facilitated by integrating it to the Twitter backend system. In the Twitter backend system, you can create an AI Guardian API whenever a tweet is submitted. So, this API is going to take the call and it will check the data, and it will verify whether it's the real or a fake tweet, and it will get back to the user and gives the permissions to post. We can create a system like this for integration with the social media platforms. When it comes to the integration with the news, you can take an example of Google News. You can integrate it like check on the news stories might be carried out integrating with the middleware AI Guardian, like in the middle, like before the data is getting posted onto the news of the Google section. you can create a middleware AI guardian system which verifies the data and the data getting posted. Next is integration with the content management system. The content producers and editors should be able to conduct real time content integrity checks within the CMS interface by using AI Guardian as a plugin SDK. You can put a menu item in the CMS system, like to verify the data which is going to be posted or before posting it. So you can add a small development or a menu item as a plugin to the CMS system. So this is as part of integration we can do uh, our fake news detection system. Coming to the conclusion, the main focus of the NLP techniques that are used as part of this project is stemming, which reduces the root to the base word, like root word. It's like work to work, working to work. In that way, lemmatization is a more advanced technique. When you take an example of changed, change, it will reduce the word to change if it is stemming by removing the letter E. But lemmatization does not do the mistake, it will reduce it to change. So the base word which is being reduced is proper in lemmatization. When it comes to the tokenization, when a sentence is given, it is divided into set of tokens, that is words. And next, stop word removal. Stop word removal can be the words like the, a, which does not add any value to the sentence. It can be removed so that the data become more clean and easy to analyze. These are the NLP techniques that are used as part of this project. When it comes to the architecture of this project, firstly we have the data set. We do the data processing. We read the data set using the read CSV and the Python. And next we check if there are any null values in the data set. And next we do the text pre-processing using the NLTK packages like tokenization, stop word removal, stemming, and lemmatization. And we apply random forest, logistic regression, support vector machine, and decision tree, different machine learning techniques to predict whether the data is real or fake. And then to bring the transparency and accountability into the results that are obtained from the machine learning models, we apply sharp and lime explainable AI techniques. Whether the results that are obtained from the machine learning models are correct or not, we use sharp and lime. And finally the prediction is like fake or real as per our data set. This is the complete architecture of the project, and thank you so much. This is all about my project.